Welcome back, statistics students. We're on to chapter 5. Okay, I'm going to be doing some chapter 5 examples. This will be example number 1. And here we have Bob. He took 2 tests on the same day, English and math. On the English test, he scored 90, where the class had a mean of 84 and a standard deviation of 3. The math test, he had an 85, and the mean was 79 and a standard deviation of 2. And clearly these are 2 different tests, 2 different scores that he got. The question is, which one did he do better relative to his classmates? Okay, because clearly he scored better on the English test compared to the math straight up, right? 90 versus 85. But if we're comparing him to his classmates, these are 2 different types of things. So it says, in which class did he do relatively better? Interpret the z-scores. This actually helps you out because it says to make a z-score. In general, you have to make a z-score if you're going to compare 2 pieces of data in separate samples, okay, which each class is a sample here. So what we do is we make a z-score for each one. I'll start by making the English one. So he has this 90 with the mean of 84 and the standard deviation of 3. Well, as always with a z-score, you should write out the formula somewhere generically. That's x minus mu over sigma, right? In this case here, okay, when we're doing his z-score for the English test, that is 90 minus 84 divided by 3. Now, do we anticipate this score, this z-score, being positive or negative? Well, he scored a 90 that averaged an 84. He's above average. Above average means that he should be above 0, which means this should be a positive score. Which, of course, when we do the math here, right, we get this to be a 6 divided by 3. We get a z-score value of 2, which is a positive 2. Okay. Now we do the z-score for his, let's get a different color here. The z-score then for his math, right, would be, well, he has an 85, a mean of 79 and a standard deviation of 2. Well, that's a z-score then for math would be an 85 minus 79 divided by 2. That is 6 divided by 2, which is a positive 3. Again, we anticipate it being positive because he's above average. This one is a 3, this one is a 2. Now, when you're comparing them, right, to figure out which one he did better in, is a big z-score better? Well, higher the z-score means higher above the average he did. Here, this 3, right, this 3 here is further from 0. So, because because his math z-score is 1 standard deviation further from the mean, he, which I could probably say his name, Bob did better relative to his classmates in math. Okay. Well, we can move on down here. It says evaluate his overall performance on the 2 tests by adding the 2 scores. Determine how he did overall for the day by interpreting the overall z-score. Well, here, this one's kind of tricky. We haven't done a whole lot with combining variables and things, but in general, he's 2 above and 3 above, right? So he is 5, Bob is 5 standard deviations above average in math and English combined. Okay, and that is the first example that we have for the z-scores. There are different ways to interpret A here, so feel free. You could have said something like English is lower, is closer to 0 than math is, so it is less of a score. Of course, if these were negative, I would want the English one because he would have been done better because it's less negative. Okay, so there's a bunch of different ways to interpret that. Just be really careful on what a positive z-score means and what a negative one means.